Leading Chinese battery firm Contemporary Amperex Technology Company Limited, or CATL for short, has just announced a battery they claim can outperform the upcoming 4680 battery by Tesla. How does this CATL plan to do this, and what revolutionary technology have they used to hit this level of energy density? More importantly, when will mass production of this battery start? Curious to find out all this and more about this new battery? Well, let's dive in. Before we start giving you the inside scoop, make sure to subscribe to the channel and like the video so that you don't miss any future updates. Done? Okay, let's get started. During a presentation at the 2022 China EV100 Forum held on March 26 in Beijing, the chief engineer of the company announced that their new CTP technology can deliver 13% more energy as compared to a 4680 battery cell of the same size and the same battery chemistry. This new battery is actually the third generation of the cell-to-pack technology and is internally referred to as the Kirin battery. The battery utilizes cell-to-pack technology and will come in two distinct variants. There's a lithium iron phosphate cell and a nickel cobalt manganese cell. For the cobalt-free LFP version, a gravimetric energy density of 160 watt-hour-kilogram and a volumetric energy density of 290 watt-hour-liter are given. For the NCM version, the values are 250 watt-hour-kilogram and 450 watt-hour-liter respectively. This higher energy density comes from the simpler and more efficient construction. According to CATL, with the groundbreaking CTP cell-to-pack technology, which simplifies the module structure, the volume utilization rate of a battery pack is increased by 20 to 30%. The number of parts in a battery pack is reduced by 40%, and production efficiency is increased by 50%. How it works. How does it work exactly? Well, cell-to-pack is when there is direct integration of cells into a battery pack, without the modules used in most current pack designs. This removes all the excess wiring and lowers the amount of space needed by the battery, leading to a lower weight and overall higher concentration of active material in the same space and weight. Since the passive material such as module sheathing and control is left out, more energy-rich material can instead be used, leading to a higher energy density. Cell-to-pack tech is used with lithium iron phosphate batteries, usually since for the NMC ones, the cells need to be prismatic. This is exactly what CATL showed during their presentation. 6 columns of 20 prismatic batteries, or 120 prismatic cells in the Kirin battery pack. Right now, CATL is supplying Tesla with lithium iron phosphate LFP cells for the base models of the Model Y and Model 3. These batteries have an energy density of 125 watt-hour-kilogram. The new cell-to-pack LFP batteries offer a 28% increase in energy density alone, which, once coupled with the decrease in weight, is going to increase range even more. Coming back to the technology itself, cell-to-pack tech is also in use by another Chinese company, which is no other than BYD and their Blade battery. This battery is actually the most widespread one, and the lithium iron phosphorus version offers 150 watt-hour-kilogram. Well, it turns out that CATL's LFP cell would also exceed this value by another 10 watt-hour-kilogram. Increased range. And that's not all. CATL also mentioned a 1,000-kilometer or 621-mile battery tech coming soon. According to the chief engineer, Wu Kai, CATL's 1,000-kilometer range heat diffusion-free battery technology will enter mass production in 2023. In case you're wondering what a heat diffusion-free battery is, it's a type of battery that doesn't explode or catch fire even if the monomer thermal runs away. This gives the passenger sufficient time to get away from the vehicle. All this is a part of the Chinese government's initiative to make EVs safer. The heat diffusion technology was first turned mainstream by CATL when they incorporated mass production of heat diffusion-free technology on its 811 models in September 2020. This was prompted by regulations issued by the Chinese Ministry of Industry and Information Technology in May 2020 that required that battery systems do not catch fire or explode within 5 minutes after the thermal runaway of the unit cell, reserving a safe escape time for electric vehicle passengers. Safety concerns. All this stems from China's concerns regarding the safety of its consumers. Batteries have seen record increase in charge capacities in recent years. Maya Wei, Deputy Director of the Economic Committee of the Chinese People's Political Consultative Conference, said, "From 2017 to 2021, the energy density of China's power battery systems is increasing, and the cost of power battery systems has fallen by 41% in 5 years. All this is a good sign, and it's clear that we're going to see an even greater increase as Tesla and other manufacturers start to shift towards their own battery-making operations. However, there is also cause for concern." BYD Chairman and President Wang Shunfu said at the forum, "When the range crosses a certain threshold, the importance of power battery energy density decreases, and the most important indicators may become safety, cost, and cycle life." CATL also talked about a combined power exchange solution. They want to separate electrical and vehicle design. This will help lower the cost of the automobile for the consumer and, at the same time, help make the power stations more accessible. If the power exchange station is compatible with different grades and various brands of vehicles, it will make the grid larger and make EVs a better option. Sodium-ion battery. We've been saving the best for last. In addition to all the other impressive upgrades CATL has made to their batteries so far, the most revolutionary one so far has been the introduction of sodium-ion batteries. As you probably know, lithium is by far the most common cathode in batteries that EVs use. The industry has been trying to come up with a suitable replacement for the lithium since it is harder to obtain, and there have been human rights concerns related to its mining in the Democratic Republic of Congo. CATL claims that they've had a breakthrough and have been successful in using sodium as a replacement for the lithium. Sodium is far more abundant than lithium, and according to CATL, it offers greater charging speeds and better performance in the low ambient temperatures. Lithium, on the other hand, has been known to struggle at lower temperatures. People have been trying to use sodium as a replacement for lithium for ages, but due to its larger molecular size, sodium doesn't offer the same energy density as lithium with a graphite anode. CATL, however, has used a graphene anode, and so far, sodium has shown to be an effective replacement. The ability of graphene to absorb and capture higher number of sodium ions was first shown by German and Russian researchers at the Helmholtz Center, Dresden-Rosendorf. If CATL is able to optimize and commercialize these cells, it will have an edge over the industry that no one else has at the moment. CATL started small-scale commercial deployment of sodium-ion battery cells in July 2021. And if everything goes according to plan, they expect to be able to ramp up the sodium-ion supply chain through to 2023. According to preliminary testing, CATL says its first generation of sodium-ion cells achieve a gravimetric energy density of 160 watt-hour kilogram. This is a bit lower than the current LFP cells, but CATL hopes that their superior performance in lower temperatures will make up for it. A solution to the lower energy density of the sodium-ion cell has been proposed by CATL themselves. They have suggested an AB cell that utilizes both the lithium ion and the sodium ions. One EV pack with both the cells could leverage the benefits of the two different technologies involved in a symbiotic relationship. To summarize, CATL, a leading Chinese battery company, just released their new third-generation cell-to-pack battery that is apparently outperforming Tesla's top-of-the-line 4680 cell. The new CTP cell is not only going to increase energy density, but it will improve range and lower the cost too. Revealed at the 2022 China EV100 Forum held on March 26 in Beijing, the new cell has a 13% greater energy as compared to the 4680 cell. And as compared to the current LFP cells being used in the Model 3 and Model Y, the new cell has a 28% higher energy density. These cells will become mainstream by 2023, and if all goes well, we might just see these in the new Tesla. Anyways, That's it for today's video. We hope you enjoyed it. Don't forget to hit the like button if you did. Also, subscribe to the channel and click on the bell icon to support us. And stay tuned. We'll see you next time. Peace.